Good morning students. This is Varsha Patil standing in front of you giving lecture on the subject Engineering Materials and Metallurgy. Now what is Engineering Material and Metallurgy is? This is nothing but the branch of science which deals with the study of the materials and its microstructure and its properties. It's called as the Engineering Materials and Metallurgy. Now in that the very first unit is crystal structure and deformation of the metal. Crystal structure, I repeat, crystal structure and deformation of the metal. We are going to study in this unit. Now, the first topic in the syllabus is basic concept of crystal structure. Now, what is crystal structure is basically, it is that we know that every material is examined on the basis of its structure, and that structure of the metal is made up of many atoms, and that atoms are arranged in a specific manner, in a specific distance, in the specific angle. That type of arrangement is called as the crystal structure. Now, there are two types of the crystal structure, or there are two types of the metals are available. Metals or non-metals are available, materials are available, that crystalline solid and non-crystalline solid. Now in the crystalline solid, we can say that the metal or the solids which are built up of crystals, and that crystals are arranged in a specific manner are called as the crystalline solid. And when that are not arranged in a specific manner, that kind of material are called as a non-crystalline solid, or it may be called as amorphous material. Now, the example of crystalline solids are iron. There are example of iron, aluminium, or some non-metals are also there. Copper. These are called as the crystalline solid. And in the non-crystalline solid, I will give the example of paper, then plastic, then glass. These are called as the non-crystalline solid. Means if we took that sample of material and observe under the X-ray, we cannot find the atoms are arranged in a specific manner. So these are two different concepts of the material, that some metals or non-metals are having crystalline material and some are having non-crystalline structure. Now we go through that concept of the crystalline solid and non-crystalline solid. Now what is exactly crystal structure is that we are going to study now. Crystal structure, if we go through the definition, crystal structure is defined as when many unit cells of atoms are arranged in repeated in a same manner and in a same dimensions are called as the crystal structure. Right? I repeat once again, you concentrate on it, that crystal structure is defined as when many unit cells, underline this word, unit cells repeat in a 3-dimension space known as crystal structure. Okay, friends, recently dealing with the definition of crystal structure, we use one word in the definition, that the many unit cells are repeated in a space. Now the next topic is what? The space lattice. Now what is the space exactly? Space lattice is defined as the infinite array of the points in which that points are in 3-dimensional, and that all points are symmetrical with each other, or symmetrical to each other with respect to each other. That is called as the space lattice. Now, after that, we are going to study the unit cell. what is unit cell? The word is unit. Unit means a single cell we are going to study over here for the crystal structure. Means it is defined as the basic structural part of the composition of a cell is called as a unit cell. Now we can see the diagram. There are three axes over here and we are going to study one cell. It's one cube that are defined, that is absolutely defined with the beta, alpha, beta and gamma angle and A, B, C parameters. Means the distance in between the every corner of the points on the axis is defined the unit cell, and angle in between the two axes means Z and Y axis made angle alpha. That angles are called as the space lattice angle of the unit cell. See, once again I repeat that it is defined as the basic structural part in the composition of the material, and unit of the length or space lattice or distance between the space lattice are point defined by A, B and C parameters, and angles are called as the lattice angle, that are nothing but alpha, beta and gamma. The space lattice is absolutely determined by intercept points like A, B and C which are shown in the diagram, and the angle that alpha, beta and gamma. See, in the previous topic we studied about the unit cell. Now different type of crystal systems are there. We may say that the types of crystal system, concentrate on the word crystal system. It has a 7 type of crystal system, that is cubic, tetragonal, orthorhombic, then rhombohedral, then hexagonal, monoclinic and triclinic. These are the 7 type of crystal systems are there. So we are going to study one by one. As we studied in the unit cell, that unit cell is defined on the parameter of A, B, C and alpha, beta, gamma. So the types of the crystal structure crystal system is depends on this parameter, that is angle and the length, height, width of the cube. So very first type of the crystal system is cubic type of crystal system. In that the length, height and width are same, means the parameter A is equal to B, B is equal to C, and the angles, that is lattice angles, are alpha is equal to beta is equal to gamma, all are 90 degree over here. So by means of these parameters we are going to draw the unit cell. See, all parameters are same. Means if we mark the parameter length is A, width is A and height is again A, and the angle in between these 3 axes, that is alpha, beta and gamma, are 90 degree only. This is what? The first type of crystal system, that is cubic. Now second is tetragonal system, in which one similarity is there, alpha, beta, gamma are remain same, that is 90 degree, and but the parameter A, B, C are not same. Means A is equal to B but not equal to C. By means of this or by taking this parameter, we are going to draw the structure tetragonal or tetragonal structure of the unit cell. Now here the length and the width is same and height is different. angle are same. That is 90 degree, 90 degree and 90 degree. That means alpha, beta and gamma are same. But only what is the difference? A is equal to B but not equal to C. So length and the width are same A but the height is C. This type of system, crystal system or unit cell is called as the tetragonal crystal system. Right? Now orthorhombic. In that the parameters are A is not equal to B is not equal to C, but the alpha, beta and gamma are remain same, that is 90 degree with each other. Now we can draw the small diagram only. That length is different, height is different and the width is also different. Only similarities are what? Angles are same. Alpha, beta and gamma are remain same, that is 90 degree, and A is not equal to B is not equal to C. This is called as the orthorhombic structure. Once again we observe the diagram that, or what is the difference in between the diagram is the parameters in the cubic structure all are same. A is equal to B, B is equal to C. And in the tetragonal A is equal to B but not equal to C. And in orthorhombic A is equal to B A is not equal to B and as well as not equal to C. But what are the similarities in these three systems? That alpha, beta and gamma all are having same angle, that is 90 degree. Now after taking the three types, that cubic, tetragonal and orthorhombic, we are going to study the next three topics of the crystal system, that is rhombohedral, hexagonal and monoclinic type of crystal system. Now in the rhombohedral we observe that parameters A, B and C, means length, height and width are same, but the angle alpha, beta and gamma is not equal to 90. We can see in the diagram. Now in the hexagonal type of crystal system, that A is equal to B but not equal to C, means length and width is same but height is not same. Here alpha and beta angle is having 90 degree angle and gamma is having 120 degree angle. We can see in the diagram that A and B are same but C is not same, and the angle alpha and beta are 90 degree and gamma is having 120 degree angle. In the similar way, in the second last topic is monoclinic, that is A is not equal to B is not equal to C, that is alpha is equal to gamma is equal to 90 degree but beta is not having 90 angle. So this is what? This is 90 degree, both alpha and gamma is having 90 degree but beta is not having 90 degree over here. We can see in the diagram. This is what? 6 type of crystal system. Now the last crystal system is triclinic. So we are going to draw it now. Last crystal system type is triclinic. Parameters A, B and C are what? A is not equal to B, not equal to C, and the angle alpha, beta and gamma are not 90 degree. All these three are not 90 degree. That means the structure will be like this. beta and gamma, all these three angles are not 90 degree, and A is not equal to B is not equal to C, means length, height and width are also not same. This is all about the crystal structure. Thank you.